Good morning to everyone. Mr. Lesham is here. Whether you're in Woodbridge, in China, in Japan, in England, wherever you are, South Africa, of course. Trig is the same Trig. Trig is the same Trig. Russia, of course. Russia, Ukraine as well. Shall we put that there? Okay. Right. We're still solving equations. Okay. In this specific example, we're going to find the general solution for a trig equation, okay? But I could easily find a solution within an interval and find a specific solution. It's going to be the same start, but what the trick we're going to have to use here, we have to use identities. So if you think about it, all the equations that we had so far, that we saw were like, 3 sine 2x plus 10 equal 4. It was only involved one trig function, a sine or cosine or tan, whatever. Now, look at this, sine theta equal cosine theta. So we've got two trig equations. What do we do? Let's pause and I really want to hear your thoughts. And Simone, that was fantastic. So what we want to do always really is, the principle is to get rid of one of them. And there's different ways of doing it. But in this specific case, what we got to do is just divide by cos. Okay, if I divide by cos, then cos divided by cos is equal to what? 1. What is sine divided by cos? Okay, I'll write it down, sine over cos, and you guys are correctly saying, oh, that's saying same as saying tan theta equal 1. And that I know how to solve. That's easy peasy. Okay? So we find the reference angle is exactly 45. Hang on, how do I start? Trig this and without my circle. Must have my circle. Okay? Theta 180 minus theta 180 plus theta 360 minus theta. Okay. So the reference angle is 45 because it's actually positive. Who's with? Where would my quadrant? Which quadrant am I looking at?
First quadrant and
the third. That's where the tan lives, where the tan angles live to get the positive answer. So my first answer is theta equal 45, and I should really add what?
360k.
Normally I will just add 360k, and then the second one will be
180 plus
45, which is 225 plus 360k. But you know, with tan, okay, we can combine them two together to give one solution. Theta equal to what?
45 plus 180.
That's it. So, you know, as I told you, okay, you can write those two solutions and combine them, or only when it comes to tan, just write the first solution, but instead of 360, put 180k. Obviously, I need to write the k. And obviously, I need to write k belong to z. Okay, so that's the answer. Pretty easy, right? I'll pause here, we'll move to the next one. Okay, guys, the next example, the same idea, but maybe one level up. What do I do here? What you want to do, don't look at the book, you want to turn it into something like that. Again, I'm stuck because I've got two, sine and cosine. I want to get rid of one of them. In fact, you can do straight away. Let's do the same thing. What should we do to get rid of one of them?
Divide by cos.
Divide by cos. Okay, yeah, let's divide by cos. So the same way, just like here we divide by cos, I'm going to get, what is sine divided? Okay, let's write it. Sine alpha over cos alpha. What is 4 cos divided by cos?
Sin over.
It's 4. Okay, let me just write it again. So I'm going to divide everything by cos.
Cool.
Do I need to divide 0 by cos? Yes, but 0 divided by anything is 0, right? And then what is 3 sine over cos? How can I write that? 3 tan. And then, as I think Jacques said there, or somebody said, that's just 4, right?
Yes.
And then we can solve that. How do we solve that? Tan theta. Let's see if we can do a two-stage one. Equal to?
Tan theta.
Minus 4 over 3. We push the 4 to the other side. Minus 4 divided by 3. And then we can solve it. Right? Shall we do it one more time for the good old days? Okay. the reference angle is going to be equal to what?
53.1.
Okay, but how do we do it? It's tan minus 1 of
4 over 3.
4 over 3. We ditch the minus, which we get 53, comma
1, 3, so.
1, 3. That means that my theta is, okay, Buzu, what do you reckon? We've got a negative, tan is negative here.
So it's between the
Which
fourth one and the second one.
The second one. So let's start with the second one. So it's 180 minus 53. Hang on. Yeah, 180 minus 53 or 13. So it's equal to 120.
126,87.
87. And I need to add how much?
360k.
Well, see what I'm going to do here is I'm not going to do the same here. I'm going to straight away add 180k. And by adding 180k, when k equal 1, that will bring me to the fourth quadrant. So I don't need to do that again, you know? So that's the general solution. I can only do that with a tan. Just instead of adding 360k, add 180k, and I only need one quadrant to sort that out. Okay?
Yes.
And then obviously I need to write k belongs to z. Okay, so that was basically solving these two problems with one identity. What is the identity that I use? Tan theta equal to?
No, -4 over.
No. For both of these, I've used sine over cos. Okay, I use that identity. Okay.
They do it wrong in the book.
Let me just pause. We'll have a look at it in a second. Whilst we're at it,
Oh, I see.
what is the next identity? There's only two identity in grade 11. That's nice. Prepare us for the next example. What's the next identity?
1 minus sine squared.
Yeah, well, it's all comes from sine squared plus cosine squared equal 1. Okay, so we're going to use that in the next example. The next example looks like that. Okay, 2 cosine squared equals sine plus 1. Now, let's see, maybe we can force and try and using that. If I divide everything by cosine, okay, if I divide everything by cosine, that's not going to help me. I mean, what will I get? I'll get 2 cosine theta, so I didn't get rid of the cosine. Then I get sine over cosine, okay, that's a tan. But I'm also going to have this weird 1 over cosine theta. There's nothing I can do with it. That's not going to help. There's no point in doing that. So I need to come up with a different plan. And the different plan is, already we prepped you here. We're going to use the other identity. Whenever you have something with cosine, something with square. Okay, if you've got something square, then you think, okay, I can replace that. So you always want to replace the one that is square. If you replace the other one, it will be more difficult. So instead of cosine square theta, what can I write? Finn already said that. 1 minus sine square theta. So I'm going to do that, okay? So, but I mustn't forget I've got a 2 in front of it. So I'm going to 2 times 1 minus square theta. 1 minus square theta. I'm going to start moving everything to this. No, I'm going to keep it there. Sinus theta plus 1. And then just open it. How do I open that? What do I get?
2
minus
2 sine squared.
2 sine square theta equals sine theta plus 1. Okay, guys, that's a quadratic function. It's a quadratic function and a trig together.
Oh no.
Okay, so we want the square bit to be positive, so I'll move it all to there. So I'm going to have 2 sine square theta plus sine theta, and then I need to move that minus 2 plus 1 will be minus 1 equal to 0. Okay, now I'm going to pause here for a second. Okay. Alright, so I've asked you around, and what you chose to, I'll use what we call the K method. So as I said, this is a quadratic function because we've got square, but it's also a trig function. It's made out of sine. So perhaps, maybe it's a little bit easier for you to make this substitution. Maybe later on you'll change your mind, but you can say, okay, I've got something square plus that something. That something is sine. So it might be, and it really isn't necessary, and as you see in the book, they don't do it. So you can say k equals sine theta. Then how would we write this equation with this substitution? 2 times 2k squared plus
K
a minus 1 equal to 0. Okay? And now that equation we can solve. Now, factorization is not so easy because I've got a 2 here, right? So what could we use maybe? We haven't used for a long time. Let's use a formula. Look, this is actually an easy one to factorize, but I think you guys like the formula, no? And it's not a bad thing to use. So let's use the formula. K equals, does anyone remember? Minus, what's the formula? X equal minus b plus minus square b square minus 4ac over 2a. Okay? Right. What is b here?
K.
Yeah, right?
It's what's in front of k. It's 1. So it's minus 1. Okay? Minus 1. Plus minus square. What is b squared?
Minus 1 squared.
1 squared. It's not minus 1. Okay, that was minus b. 1 squared minus 4 times a. What is a?
2 times
2.
minus 1.
And c is minus 1. Okay,
Over 4.
divided by 2a,
4.
2 times 2. Okay, so k is equal to minus 1 divided by 4 plus minus 1 plus 8 is square root 9, right? Convince yourself you're happy with that. You can put it in a calculator, but I just had 1 plus 8. Okay? Luckily, that's a perfect square. Okay? So we have minus 1 plus minus 3 divided by 4. So my k's are what?
1,
Minus 1. Okay, if I do minus 1 minus 3 will be
Plus
minus 4.
Plus.
Not plus 1. Half. If I do minus 1 plus 3, it's going to be plus 2. 2 divided by 4 is half. Let's just pause here, see that you're happy with that. Okay guys, I mean, just before we carry on, okay, those of you, maybe later on when you're a little bit more comfortable, you can say, you didn't really have to do this case substitution. You can say, okay, that's my x squared, that's my x, and that's, so you know that you could have just written equally, you could have just said sine theta equal to minus b. What is the b? B is what's in front of the sine theta, so minus 1. Plus minus 1 squared. Minus 4 times, what is the a? A is what's in front of the sine squared. 4 times 2. You can carry on just in the same way. You will get the same thing. Instead of calling it k, you will say straight away sine theta equal minus 1 or half. Okay? If you chose to do this case substitution, then you need to go from here. Maybe it's a bit longer, but maybe a bit clearer. You just got to remember that k equals sine theta. So if k equals minus 1 or half, that means the sine theta is equal minus 1 or half. Are you happy with that? Okay? So, like I told you in the beginning, this is a quadratic and a trig function at the same time. So we finished the quadratic bit. We found the quadratic solution. And now we got to start the trig solution, okay? So the quadratic equation told us that there's two possibilities. Either sine theta is equal minus 1 or sine theta equal half. Now we need to solve that one. So let's move on to the sine area. The trig area. So I'm going to start here. I'm going to write down, right in blue. Sine theta equal minus 1 or sine theta equal half. And we know how to solve these problems, right? It's a little bit of a diagonally. Let's move it here. Okay. These are very easy, okay? Sine theta equal 1, how do we do it? We always start with a reference angle. What is the reference angle? That's actually a special angle. Minus 1 is going to be, in fact, it's going to be 2. And that's an interesting one. We've never actually done it. Okay? When is, I need to draw the circle here because you can't see it. Okay? For which, what is sine theta? Sine theta, if I draw a little triangle here, we'll give it a different color. Okay, this is my theta, this is my x, this is my y. Okay? Sine theta is y over r, right? Now, I want that to be minus 1. When is it going to be minus 1?
On R is 1.
Okay. It's when it's here. In other words, y must be equal to minus r. Okay? In other words, it's 270. But you know what? Yeah, it is something that you should know at some point. But don't worry if you don't know it, because actually I shouldn't have written 270. We need to find the reference angle. Okay, so don't worry too much about y. Okay? What is the reference angle? The reference angle is sine minus 1 of what number? 1. Okay, let's keep it simple, Mr. Leach. Let's keep it simple. You can use a calculator for that. What is that? 90. Okay. So that would be the angle if the equation was sine theta equal to 1. Yeah? But the question is sine theta equal to minus 1. So which quadrant do I live? Which quadrant will be my solutions for negative sign? When do I have negative signs? Which quadrant?
Third and fourth.
Third and fourth. So how do I go? Okay, I need to again draw my little thingies here. Theta 118 minus theta, 180 plus theta, 360 minus theta. Okay, it's going to be an interesting one, this one, right? Okay, how do I move from 90 to where I want, to the third quadrant? What do I do?
180 plus.
980, 980, 90 plus 180, right?
Yes.
The same.
Plus
How much
three-
is that?
60k plus 360.
Plus 360k. Yeah. Plus 360k. Absolutely right. How much is that? What is 90 plus 180? 270 plus 360k. Okay? Now that's just one quadrant. I can check the fourth quadrant, right? You said fourth quadrant also give you negative. So how would I do the fourth quadrant? I'm going to take the reference angle, 90, and what should I do with it?
It's going to be 270.
It's going to be, how do I do it? I do 360 minus 90 plus 360. It's still going to be 270.
Plus 260k.
So we're getting the same answer. Okay? There are specific angles that only have one solution. And they are really 1 minus 1. 0, yeah, let's just see that. Okay? So, but anyway, you get the same answer. We can talk about why that happens. I did it a little bit when I explained in the beginning, but I don't know how clear that was. Let's just keep it like that. So that's one answer. Is that all the answers? That's the answer for this one.
Yes.
Well, I have another one, don't I? Yeah. Okay? So the quadratic equation, okay, the quadratic equation you can see here, gave us two solutions. Okay? And now I need to carry on to find those solutions for these solutions. Okay? So we're going to have more solutions. Right. This one, sine theta equal half. Okay? That means the reference angle is equal to what? That's a special angle. Maybe you can figure it out. 30. Nice one. Okay? Now, that means that theta is equal, because it is really half, which quadrant are they going to be? Sign is positive here.
First and second.
First and second. So the first one is going to be 30 plus 360k. And the second one is going to be, how do I get the second one? 180 minus 30, which is 150 plus 360k. Can I combine them to 180 or something like that?
No.
No, it only works with tan. You can try. You add 180, that's not going to be there. So this is also a solution. So these are all the solutions. Okay? Where we write k belong to z. So we've got 3 classes of solutions. Not 3 solutions. We actually have infinite number of solutions. Because you can put k equals 0, k equal 1, k equal minus 7. Right, I'll pause here. This last example, I'm not going to solve it all the way, just going to get it started. Because you can do a really not clever move here. 5 cosine square theta plus cosine theta. What do you reckon we should do?
Divide by cos? No.
Because then we get to 5 cos
Yeah.
plus 1.
Yeah, it's okay. If you divide by cos, let's write it down in a different color. If you divide by cos, you're right, you're going to get 5 cos theta plus 1, which equals 0, which you can solve. That's true. but you will get half, you're going to miss a solution. What you want to would we want to change it to 1 minus square theta?
Yes.
I told you.
Yeah.
Why would that be not a very good idea?
Because you're gonna have sine and
Then I've got a sine and a cosine. That's going to be 5 times 1 sine square theta. But then I have still cos theta. So I did exactly the opposite to what I want to. I want it to be the same trig function. It's already the same trig function. So I definitely don't want to change it to 1 minus sine. What I want to do is take a common factor. If you can take a common factor, always take a common factor. What's the common factor?
Cos.
Cos. So we're going to have cosine theta times 5
5
cos theta
plus 1.
plus 1 equals 0. Okay? Now, I've got something times something equal to 0. What will be my possible solution? There's two possible solutions. It's a quadratic equation.
Cos theta equals
0.
So one option, cos theta equal to 0, and the other option,
5 cos theta plus 1 equals 0. And it's solved.
okay? Okay, so I've got two options. Either this one is 0, which Simon already predicted, but by dividing by cosine theta, he lost this solution. You see, that's another option. Okay? So when I have a square, but it's the same trig function, don't use that identity. Just take a common factor, okay? Or even, I mean, I could maybe look later on and you can probably do it yourself. I'm not going to show you example, but let's say I'm just looking for an example here. I can't really find, but let's say I had 2 cosine square theta plus 3 cos theta plus 1. If I've got something like that, and it's not very easy to take a factor, what could I do? How could I solve that?
Move the 1.
No, because that only works when this is 0. K method. Then I'm going to do a K method, okay? Right? So I'm going to call, what is K going to be?
Cos.
Cos.
K
So I'm going to write 2k squared plus 3k plus 1, which hopefully has a solution. I just made it up, so maybe there's no solution to it. But, you know, don't try and solve it. Definitely don't copy it. It probably doesn't have solutions, okay? But that's the idea, okay? If it's the same trig function, just solve do the K method, or if it's easy, just take a factor out, find the solution, the quadratic solution, then find the trig solution. I'll stop here. Let's practice it. Bye-bye.